Happy Monday. We made it. After 5 days of antibiotics, I'm feeling a whole lot better. Good stuff. Modern medicine is good. We made it through. So thanks for your flexibility. We will have lab today. We missed a little. I'm sorry. We'll pick it up today. It won't be the end of the world. We'll get lots of practice in throughout. So I wouldn't worry too much about it. So we're going to get into loops today. More on loops. We got started on Wednesday, right? On loops? No? Oh, we just got branching. Okay, just branching. So that's okay. I'm trying to remember now. It takes my brain a little while. They didn't have Diet Coke, so I'm on regular Coke, which is really bad for my sugar. So I'm trying to stay right in the middle here. If I go too low, it's bad. If I go too high, it's bad. It's lots of fun, but I drank all my coffee already. So I had a 9:30 meeting here on campus. It was awful. Morning meetings are the worst thing ever, but it was the only time the dean had available. So I was like, okay, sure. I'll come in early. All right, so we're going to jump into chapter 5, loops here. And I did have this awesome flow chart here I wanted to share. I put this in the Discord channel. Thinking about how to use ChatGPT style tools ethically, correctly here. So the first part here is, does it matter if the output's true? If no, sure, go for it. It doesn't matter, right? These large language model tools are prose machines. Their job is to imitate and say, okay, based on this question, this is what normally would follow. Now, they've been trained and then they get pretty good at it, but they're made to be prose machines. They're not made to be fact machines. It's just giving you something that looks like an answer that would follow. Turns out they're really bad at math. They can do 2-digit math, but if you start giving out 3-digit math, it's like, oh, sure, I see 3 numbers and 3 more numbers. I'll just give you 6 numbers. And it just makes crap up. It's kind of funny sometimes. Someone posted a funny thing. I think I shared that one. They said, hey, if it takes me 10 minutes to dry my towels on the hanging line, to dry 2 towels on a hanging line, how long would it take me to dry 10 towels on a hanging line? It's like, oh, well, 10 divided by 2 is 5. 5 times 10 is 50. It'll take you 50 minutes. And you're like, no, it takes 10 minutes. Because you just add more towels on the line outside. So there's things it's bad at, right? So if it doesn't matter if the output's true, then go for it. Have some fun with it. It's a fantastic tool. It does a lot of cool things. If it does matter, this little diamond here, this little decision point, is sort of the crux of the whole reason you're in school, hopefully. And I get how the real world works and things, and you have to get paper, and you have to have certain scores and things like that. But essentially, do you have the expertise to verify the output is accurate? If you don't know what the hell you're doing, then no, don't use it. Because you don't know if it's right or wrong, right? You have to build that expertise, and ideally that's why you're here in school, is to learn some things. That's hopefully the goal, and sure, we can have all sorts of debates about that. But you're building up that expertise to be able to say, okay, is what it's doing correct? Then, are you able and willing to take full responsibility, legal, moral, etc., for missed inaccuracies? If you're willing to do that, then yeah, you could probably use ChatGPT. If you're not willing to do that, then don't do it. Right? This idea, we're building up the skills, and it's still possible to miss things. Right? Are you willing to take responsibility for that? Now, we haven't got to a whole ethics talk. We'll get to that next semester. But I learned a fun fact. So civil engineers, like the people who build bridges and roads and these sorts of really cool big projects, the chief engineer of a bridge building project has personal liability on the bridge. If the bridge fails because they cut corners and didn't follow proper engineering standards, they are personally liable for it. Now, we don't have that in the software world, which is really nice. No one's going to come sue us because our software is screwed up, which is good, right? So, I think I've pointed out before, I've got this little insulin pump in my pocket. This thing gives me insulin because my pancreas doesn't work. If this thing screws up, I'm literally dead. But I can't go sue Dexcom, because they went through all the process and the FDA said, yeah, it's fine. So, there's processes. There's things that matter. So if you can take responsibility for it, go for it. If you're not, don't. So what we're trying to do is build the skills to help us take all these pieces, take all these tools and techniques, and solve problems. Right? The hard part of writing programs is not making the computer understand Python code. Anybody can write Python code. You say print. It's not hard. What the hard part is problem solving. How do I take a big problem conceptually and break it down into smaller and smaller and smaller and smaller pieces, into small enough pieces that a stupid computer can solve it? Right? That's the hard part. That's why it's a creative mental task. That's why a lot of people want to do it, because it's interesting work usually, but it's hard. You have to learn a lot of skills. It's not just, hey, plug something into a chatbot and take whatever it answers and spit it right back out. Now we're getting close. Like, it can do some basic things, but it's not doing everything, and it's bad at a lot of things. And people are working on it. We got really smart people working on those sorts of things, but I don't see the human creativity part going away, because robots aren't creative. Computers aren't creative. They can imitate. They're imitation machines. So sure, they can imitate a lot of things, but they're not going to be creative. So we'll see. All right, so moving on to our Zybooks here. Got to go to the next chapter, which one is this one here. So moving on to loops. So far in our code, PyCharm, we've been able to say, okay, hey, if something is true, let's do this. If it's not true, let's do something else. Right? This idea with our branching here. And I think we got through all the branching, right? Yeah, we got even the conditional expressions, which are crazy, like a one-liner instead of an if-else branch. Okay, cool. So hopefully the labs were fun. You're all following with the labs, right? It's a lot of work if you're not. I think you've seen it is a lot of work just to do them. Right? It's good practice. Right? The whole idea is the more you write code, the better you get at it, just like anything else. So you're going to practice a lot, and you get points for it at least for doing your practice. Free points, which is great. Yeah. Yeah, 10%. Yep. Yeah, so that's when at the end of the semester, I'll take your Zybooks participation, and that makes 10% of your final score. And along with all the labs that we do on lab day is another 10%. So like 20% just for doing it, just for showing up, trying. It's not too shabby, right? All right, so moving on to loops then. So we were able to do a couple things, right? This lotto number, we did a bunch, but having to do this 5 times was really annoying, right? To say, hey, let's enter a number, let's enter a number, let's enter a number, let's enter a number. Like, feels bad to have it to copy paste. And then if I want to change something, like, hey, let's do a different lotto where you pick the numbers 1 to 88 because we're doing Keno or whatever nonsense, like, that's a lot of things to change. So there's better options. Go figure. So let's start up a new project here. This is chapter 5. So I'm going to call this chapter 5 loops. I'm putting that in my GitHub repository. Again, so you'll be able to see all the stuff that I do. I'll put it there. Oh, I forgot to do last classes, didn't I? 150. Or chapter 4. There we go. This was C++. Such an ugly language. Come on. Just thinking about it. Let's go, little computer. All right, we'll go back to our class. So 1501. There you go. It says, hey, I found a new file. Fantastic. So I got it in the right spot. Life is good. I can get rid of the garbage starter code. So let's do a number guessing game. Because the guess a number game, that's always fun, right? It's entertaining the first time at least. So if we want I don't know, how about the number to guess? Number to guess is equal to a random number. And if we want a random number, we're going to import random. Or random. So what do you want to guess a number? Like 1 to 100? Randint 1 to 100. And then we can get a guess. Right, so our guess will be int of an input, guess a number 1 to 100. Right? All right, now they're either going to guess too high, too low, or they got it right. One of those 3 things will happen. Okay, so we can say, hey, if my guess is less than the number to guess, we didn't do this already, did we? I didn't think I saw. Okay, cool. Then we'll print too low. Elif, the guess is, how about greater than the number to guess? Print too high. And then else, if it's not too low, it's not too high, print you guessed it. Great. But now if I want them to guess again, right, I've got to copy paste this sort of thing. This starts to get really ugly. So what do we want to do instead? So if we're just kind of saying this in English, what would you say? We're going to keep guessing until we get it right? Or if you wanted to flip it, we can say, we'll keep guessing as long as we're wrong. So while we're guessing wrong, we can keep going, keep guessing. So eventually you might find the word while in English. And it turns out while is a keyword in Python that lets us continue doing something over and over and over while something is true. So instead of saying, too high, too low, you guessed it, and copy pasting here, I can say while my guess does not equal the number to guess. And I'm going to use a colon. So just like an if block, we have a colon, and then everything that's indented inside of it belongs to this block of code. And what's going to happen here now, it's going to say, okay, as long as you didn't guess the number to guess, it's going to say, is this true? So you give me a guess. If this is true, which in our case is not the right number, this block of code will run. We'll tell them too high or too low, and then we're going to ask them to guess again. So I'm going to take this line and we'll just drop it in here. Guess again. When you guess the right number, eventually this will no longer be true, and then the loop will stop running. So it runs as long as the expression is true. Right? Just like an if block, but it's going to keep repeating. It's going to run again, and run again, and run again, and run again. So an if will just run once if it's true. A while will run over and over and over. So it starts at the top, goes all the way down to the bottom, and it comes back up to the top and says, okay, now are we true? If we're true, run again. Go all the way down, get to the bottom. All right, are we true? Come back up to the top. If we're true, run again. If we're true, run again. If we're true, run again. So I can guess and guess and guess and guess. When it's done, then the code just comes right back, just like it was an if statement, and keeps on running the next line. So after here, we can say you guessed it. Because you can't get to line 17 until this is no longer true. Right? You are literally stuck here over and over and over and over and over and over until it's no longer true. In our case, being no longer true means you did guess it. Because we're checking if you did not guess it right. We want to keep on running. Okay, so we should be able to do this here, and we should be able to guess a number 1 to 100. It's very exciting. And you all know how to play the number guessing game, right? You split the difference. You always go to the middle. So 50 is too low, 75 is too low, 87 is too high. All right, so somewhere between 75 and 87. About 81. 81 is too high, 78. 78 is too low, about 80. And we guessed it. So our random number was 80. It took 1, 2, 3, 4, 5, 6 guesses. Not too shabby. Right? If we do it again, we should get a different random number. I know you're very excited. Let's run it again. So 50. Too high, all right, 25, too low, 37, too high, all right, how about 29, it's too low, 32 is too high, 30? Oh, 31, okay, so 1, 2, 3, 4, 5, 6, 7 guesses that time. I think that's about the most guesses you'll ever need. It's about 7, right? Because we keep on cutting it in half and half and half and half. And all you folks who like math, we're taking the log. Right? It's a log of the top number. If we keep cutting it in half and half, like the max guesses, be logarithmically shaped. I think so. That sounds right. You're all smiling and nodding, so it's probably right. All right. Now, I don't like having to count how many guesses it took me, right? So what if I wanted to count how many guesses it took? We could do that. So this is number of guesses equals 1. And then if you didn't get it right, we'll take my number of guesses plus 1. This plus equals 1, right? That's a shortcut for add 1 and assign it back. Right? You look at these combined assignment operators. Not sure if you're, okay, cool. Someone's nodding. That's good. So now we'll tell you guessed it in, and I like these formatted strings. We did formatted strings, right? I can say number of guesses, number of guesses. Guesses? So we'll count it for them and tell them how many guesses it took. All right, guess number 1 to 100. So 50, 25, 37, 28, 31. Hey, 5 guesses. There we go. We're getting better. Right? This is kind of boring. Right? But again, we're guessing numbers. We're having fun. Right? And now I don't have this same bunch of code repeated. I didn't have to copy paste it because I'm using a while loop. It's going to keep on running while this is true. Now it's possible I just guessed the number of the very first guess. Now it's really hard to do. So I'm going to come in here and on the line numbers, if you notice if I hover over them, a big red dot shows up. That's called a breakpoint. So instead of hitting run, I'm going to hit the bug option here. This is debugging. When you debug your program, it will pause when it gets to one of these breakpoints and you can see what all the variables are. So anything we've given a value here. So number to guess happens to be 73. I can see it down here. Right, number to guess is 73. So I'm going to flip over to console. I'm sorry. So it's waiting to run this line. So I've got a couple buttons. I have the step over is mostly what we're going to use for now. So step over will run this line. So I'm going to use step over. I said, okay, now it's waiting to guess a number. So I'm going to guess 73. And I said, okay, here's the next line. It's about to run the line number of guesses equals 1. So we can watch it run one line at a time. And I'll see, okay, now number of guesses is 1. Number of guesses is 73. My guess is 73. I can step over. The while loop doesn't run at all. It's a pre-test loop. It's tested first to see if it's true. If it's not true, it doesn't run. So we guessed it in one guess. One guesses. Okay, I feel a little bad that's bad English, but most people won't guess the number in one guess. So it's probably okay. And I'm going to put a colon in the space in here just to make it look a little nicer. All right, so that's sort of fun. We can guess a number. Now, what if we wanted to guess different numbers? What if I wanted to say, like, let's guess 1 to 1,000,000, or let the user pick 1 to 10 if they don't want to guess anything? Right? We can ask them, right? We can have a max number. Max number is an int of an input. How high of a number you want to guess? And then instead of 100 here, we'll use max number. You tell me. And then instead of 1 to 100 here, it's 1 to max number. Yeah, he even added the F for me. I'm so excited. I'm going to copy this line here because we have it repeated over here. There we go. All right, let's give that a run. So now we can say, okay, how high of a number do you want to guess? Which we guess into? Yeah. How do I know where it ends? So because everything's indented, there's sort of like this visual cue that this starts in one tab, so I know it belongs to this one. You can kind of see there's like these thin lines. It's kind of hard to see on the monitor there to show where the tabs are. So it's a little tricky sometimes, but usually you can see just visually where it goes. And if your code's not zoomed in so far, it's a little easier to see more of it on the screen. You can see that block kind of all being tabbed in there at once. So once we get back to here, this print line, it's no longer tabbed, so it doesn't belong to this block here. And then PyCharm lets you, if you're like on the while loop, there's a little down arrow here, it will collapse that loop and hide all those lines if you don't want to see them. You can also use that just to quickly jump and say, okay, where does it end here as well? Because all the visual cues are nice. All right, so how high of a number should we guess? Should we guess 1 to like 1,000,000? All right, we're going to guess the number 1 to 1,000,000. So 500,000. It's too low. All right, so 750,000. Too high. All right, 670,000 or something like that. That's too low. Okay, so 71,000 or 710,000. Too low. 730,000. It's too high. 720,000. It's too high. All right, so somewhere between 710,000, 720,000. So 715,000. It's too low. Okay, so 718,000. It's too high, 717,000. Too low. Okay, so we're within 1,000 now, right? You're very excited. This is thrilling. Very thrilling, right? 717,500, 717,750, 717,680, 717,720, 717,700, 717,100. No, so it's between 720 and 700. Okay, so 710. Too high, 717,705. Too high, 717,703. Too low. Oh, we got it now. 717,704. 18 guesses to guess number 1 to 1,000,000. That's not too shabby. Not too shabby, right? So it'll just keep on going. Now, if you wanted to do it the dumb way, you're welcome to do that. Let's guess a number. Just go 1 to 10 here. 1, 2. Oh, it was 2. Okay. I thought I had to enter more numbers here. But you don't have to cut the difference every time, right? As long as the user keeps entering something, or what if I say 10, and I give it 0, 0, 0, 0, 0. It will happily keep running and keep running and keep running and keep running because that's what we told it to do, right? It will literally run until it gets something that is no longer true. So we're kind of relying on the user here to do the right thing and interact with it correctly, but generally, users will try and do that. It should probably give us the right input, and that's fine if they don't. So here's our guessing game. Now, what might be nice, right, is if they give me something that's not a valid number, we should tell them it's not a valid number, right? Like 0 is not a valid guess, right? Should we tell them 0 is not a valid guess? Okay, we can do that. So, all right, while the guess is not the number to guess, now before I check for too high, too low, right, I want to check to see if it's valid or not. So I'm going to say, right after I get the guess here, I'm going to say, while my guess is less than 1, right, it's invalid. But then I also need to check for if it's more than the max number, right? And remember, I looked at those logical operators. I can say if it's less than 1 or the guess is greater than the max number, right? If either one of these is true, let's ask them again. Right? If either one is true, we'll ask them again. If neither is true, because they are between 1 and max, great, we're good. We don't ask them again. So this will only run if they give me an invalid input. So we call this a validation loop. Right? It's validating that we're getting input that is valid. Right? This is something I expect here. Now, numerics are pretty easy because it's just a range. Right? That works out pretty well. Now, what if we wanted to do, say, rock, paper, scissors? Right? Do we do rock, paper, scissors? We didn't do that one yet? Okay, that's fine. Rock, paper, scissors is always fun. So we'll ask them, hey, so our choice is an input of rock, paper, or scissors. I guess we should capitalize those, right? Rock, paper, scissors. And we're going to say while. Now, we've got some options here. We can say choice does not equal rock, and choice does not equal paper, right? And choice does not equal scissors. Now, this is the slow way. We can do this, though, right? If it's not rock, and it's not paper, and it's not scissors, right? It is invalid. If any one of these is false, because we're anding, the whole thing will be false. So if you are rock, false. If you are paper, false. If you are scissors, false. Right? But this is sort of verbose, and we use Python because we're nice. Python is fantastic. So instead of doing it that way, we can have this is a list of, I don't know, options. We can say options is a list, or maybe even a tuple here. We can have rock, paper, and scissors here, right? And I'm going to take their input, I'm going to go to lower, right? Let's lowercase their input. That way it matches better. And I can say, while choice is not in options. This is a little bit more Python idiomatic. Right? We can say as long as it's not in the list here, or not in the tuple here, of valid options. It does the exact same thing. It's not this one, and it's not this one, and it's not this one. This is just a little quicker to read. Right? We say, okay, if it's not in my valid list, right? Maybe we call these valid options. How about that? It's a nice way to put it. If it's not in the valid options, ask them again. Right? If it's not in the valid options, ask them again. If it's not in the valid options, ask them again. Right? So you can't get out of this loop here until you give me something that's valid. Now, it's not numeric based, like my number guessing game. This is string based, right? Is it one of the valid options here of my strings? Did you give me something that's a good choice? Right? And I think if we come back here and look at this thing over here, right? There's a bunch of valid options you can do. If it's not a valid option, right, tell them what the valid options are. So this is one possible way of doing that, right? We're using a validation loop. Is your input good? Sure, that's one way. Right? It doesn't have to happen this way, but that's one choice. Okay, got lots of fun ways to do it. But we can validate. Right? So now that I've entered rock, paper, scissors, how do I make the computer pick one? Well, the computer can pick numbers really easily. Okay, I can do random numbers really quick. So how about computer? Choice is random.randint. Now, this is like the slow way here. I can say, okay, random 1 to 3, and then I can say, hey, if my computer choice is equal to 1, then we have a computer throw equals nothing for right now. So if computer choice is 1, we'll say my computer throw is equal to rock, right? If my computer choice is equal to 2, my computer throw is equal to paper. Oh goodness, it's too many letters, right? And if it's not a 1, it's not a 2, then my computer throw has got to be scissors, right? This is probably the way we would think to do this, right? But if you spend any time Googling, Fine, go for it. How do you get a random value in Python? You can also say, hey, my computer throw is going to equal random choice of my valid options. Random choice will give you one random value out of a list or a tuple, right? So this is like the shortcut. And it's worked really nice because we already have a list of valid choices really nicely, right? Again, it's going to do the exact same thing. Now, if you don't know what random choice is, we just go Google it, right? So Python random choice. The choice method. W3 schools. Yeah, why not? Returns a random element from a list. Sure. Returns a randomly selected element from the specified sequence. It can be a string, a range, a list, a tuple, any kind of sequence. Right? We know there's lots of sequence types in Python. Cool. So again, shortcut, great. Do it the slow way, that's fine too. No, like, it will do the exact same thing for you here. Most people like to type less. That's all. If you're getting paid based on how many lines of code you write in a day, because your employer is stupid and doesn't know how code works, do it the long way, right? Like, go for it. Otherwise, take the lazy route and go this way. Sorry, one sec. All right. Other fun things we can do with loops. So what if I were to ask you, said, hey, I'm going to tell you a bunch of numbers. You need to tell me which is the largest number in this list of numbers. I say 7, 15, 4, 20, 11, 9, 1. What was the highest number? It is 20. It's okay. It didn't go how I expected, but that's all right. So what are you doing in your head when I'm shouting out numbers to see which one is the largest number? What's happening in your head? Yeah.
Just wait for the highest number, and then when we say one that's higher, keep that.
Yeah, so you're keeping track of what the highest is, and you're saying every new number is it higher. That's exactly what we do. So I can have a highest number. Now, my highest number, I'm going to start at 0 because I need to start low to start comparing, right? And I can say, how about while I will have, say, number, an int of an input, enter a number, or 0 to stop. And then while number does not equal 0, let's keep on going. And I can check, hey, if number is greater than the highest number, then my highest number is the number, right? Change the value of highest number. Oh, my computer got really laggy. That's it. And then we ask them again, right? So starts off really low because the first number should be higher than that number, right? Any number. If people really want to be pedantic and be silly with you, they'll give you negatives, and maybe we want to start this really like as a really low negative. Most people won't mess with you like that. It's just really obnoxious people like me. We'll do stuff that to you. So if you thought your parents were lame, just imagine having a computer science prof as your parent. My poor kids, I mess with them all the time, and they don't think it's funny, but it amuses me. So I don't know. You have to be very specific with your words, right? You say a number, I'll give you a negative number. They're like, Dad, why? All right, the highest number. So we can pretty quickly check, hey, is it bigger? If it is, great, it's the new highest. That's the only one we need to focus on, right? Here's the highest number. Sure, so we can do that. So let's give it some numbers here. Let's run just this bit here. So I'll run selected code. I'm remembering here. All right, so enter a number. 1, 10, 15. Oh, I didn't actually do anything with it. I forgot I should print when I'm done. But when the loop is done, we'll print highest number is highest number. All right, we should stop that. We should run the whole thing one more time with that last line. Okay, now it'll actually spit something out. So shout some numbers out at me. Let's put them in. 5. Any number. 8. 7. 200. 6. 11. 1, okay. 0, thank you. Someone got it to stop. Yeah, all right. And the highest number was 200. Go figure. It can figure out what the highest number is. So these sort of loops here are really nice because they'll just keep running until the user gives you something to make it stop. So a lot of times we call this a sentinel value. Like 0 is probably not a number most people give you. And if you talk to mathematicians, I think they tell you that 0 is not actually a real number. I don't understand how that works. Like pure math just hurts my head. Like math theory is just in another world. I don't understand it. That's okay. I don't have to. How is 0 not a number? But, okay. So this is a specific value that means, okay, keep on going until I want to be done. Right? We can do something like that. So that's a sentinel value to let me keep adding things in here, and we'll keep on going. So another thing you might do is maybe at the end of the day, you have to total up all the receipts in your drawer if you're working some sort of retail job. So I might have a total of 0, and then I'll have a receipt. Now I'm going to start receipt at 1, and I'm going to say while did I spell that wrong? EPT? I spelled, no, is that still wrong? Rename. Did it not rename? Rename to receipt. I before E except after C. Okay. Well, there's a bunch of weird ones here because English is hard, was it? Or E except after C. Exceptions. Here we go. There's a whole funny list of exceptions. The exceptions. Where is it here? When it's wrong. There's a funny saying. Okay, whatever. It's not worth it. It was going to come up quick and it didn't. But there's like a funny list. All right, so we're going to say while my receipt is not 0, we'll ask for a receipt. So this way I'm setting this up so that it will run once for sure. So in this case, we said, okay, give me a number or 0 to stop, and I had to do it again. And I felt a little bad with the same prompt more than once. So if I don't want to have to prompt first and then prompt again, I can just start the value of something to make sure that it will run. This is a throwaway value. So make sure the loop runs once. And then inside the loop then, I can ask them, right, or probably a float, right, because maybe it's a float. So here's a total. No. Value is a float of an input. Enter a receipt or 0 to stop. Great. And I'll take that value. I'm going to take my total, and I'm going to add the receipt to it. I'm sorry, the value to it. No, single receipt. I don't know what I'm doing here. Receipt. Here we go. So we'll add one receipt. Enter the receipt. Okay, $15, $2.99, $3.29, whatever we keep adding, and we'll just keep adding it to the total. Eventually, when you're done, you'll enter 0. So again, this sentinel value, you probably don't have a receipt in your drawer for $0. Stores try not to give things away for free because they'll go out of business. Right? Eventually, you run out of free stuff. Right? They just keep on going. Now, this was fun, but what if we wanted to get the average? Right? Well, if I want an average, I need to know how many items we're doing here. So I need an item count or receipt count, right? So receipt count starts at 0, and every time you add a receipt here, receipt count plus 1, we'll add a receipt. We'll add a receipt, we'll add a receipt, we'll add a receipt, we'll add a receipt, right? And then when we're done here, we can print total receipts is my total, and average is my total divided by the receipt count. Right? It should total an average for us. Let's give it a try. Oh, we just want this block here. Let me stop that. Let's just run this one here. All right, so how about 10 and 20 and 30 and 0 to stop? Total was 60, average was 15. Oh, no, that's not right. Average is wrong. Well, I counted 0, right? I added in 0 here, and then I counted the receipt as 0. Well, that's no fun. So, okay, well, we can change that. So my receipt count then, let's say if my receipt does not equal 0, let's count it. right? So if I enter 0, it doesn't get counted. We could do that, right? That's a lot of work. So this is one option here, to have another if check. At the end, I could just take away 1. I could start at -1 if I wanted. I got lots of choices, right? However we want to handle it, it's okay. This is probably the most sensical one. It might not be the most efficient, but it'll be okay. Right? So now let's try it again. So we'll say, okay, as long as it's not 0, let's count it as a receipt. So 10 and 20 and 30, and then 0 to stop. We get average of 20, total 60. That looks good. Right? We entered 3 values, the 0 to stop, life is good. All right. So I can use my while loops for a couple fun things, right? I can just keep on going while something's true, right? I can use a validation loop, the while loop. I can keep on going until I enter that sentinel value. I can find highest, I can find lowest, I can find average, all those sorts of fun things, right? Eventually we could find standard deviation if you wanted to care about standard deviation, which is a lot of fun. We'll do that in lab because standard deviation is really fun. Now to do that, though, you have to keep all the values around. So we can use a list, right? You can keep on appending item to a list, and then you don't have to count how many things you've added to the list, right? Because the list will tell you the length. You can ask for the length of a list. Just don't add 0 to the list. That's kind of the trick there. So we'll talk about that in lab. We do our lab for loops. All right. The next fun thing you can do is you can do a different kind of loop. So these are while loops. So while something's true, there's another kind of loop we're going to look at that we can use. Where'd it go? A for loop. So a for loop will do, now this is very different in Python than other languages. So other language for loops do not act like this, and that's okay. This is a Python for loop. So we can say for every item in a collection, do something. So for loop, for every item in a collection is what the for loop does. So I can say for, and now I need to give it a name. So I need a little shortcut here. So I'm going to say for, how about letter in Eric. So remember, strings are collections. They're a sequence. So for every letter in Eric, I'm going to do something. In this case, I can print letter. Not very exciting, but I'll get the E, and then I'll get the R, then I'll get the I, then I'll get the C. So what it does is every time the loop runs, it will grab the next available item. So for every item in the collection, the first one is E, this loop will run. Everything inside this code block runs. The next letter in the collection is R, the loop runs. The next letter in the collection is I, the loop runs. The next letter in the collection is C, the loop runs. Right? Maybe we want to uppercase these here. So let's letter upper. Yeah, let's put it uppercase. So if I write my name in all uppercase, you know I'm shouting, and I'm definitely going to win my arguments online. Because you have to shout at people online to win arguments, right? So let's just run this here. And we get E-R-I-C in all uppercase. They're all on their own line. That's okay. We can change that if we want it here. You can say, hey, you want to end with a nothing character here. And when the loop is done, I'm just going to print a nothing here to get a blank line, right? So it'll go down a line. We execute that. Now Eric will show up on one line. There we go. Me, Eric. Angry Eric. I'm all uppercase. So for some collection here. And it could be for anything, right? We don't need to have to give it something here. We could give it some sort of list, right? I could, hey, say, what do we want here? So like, how about colors? Equals a list of red and orange and yellow and green and blue. I don't know how to spell indigo, so I'm going to go right to purple. Is that okay? It's fine. So I can say for. Now, this part here is just a variable name, right? So we're saying for variable name for single item in collection. Right, so I can say for color in colors. Just a lot of times if you have something plural, you can use the singular. Just a convention. I could say for A in colors. Don't ever use A as a variable name, right? It's a terrible variable name because no one knows what an A is, right? But it's just our name here, and I can print the color. Right? So now I can go through, so this is iterating over every item in the collection. Iterating is our fancy term for it, right? It will, one at a time, go to the first one, and then iterate, go to the next one, 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 iterate. So we can run, oops, we don't want that. We want just run our selected code here. And it should do what we expect. It should print out every color. Right? Red, orange, yellow, green, blue, purple. Easy. And for every item in that collection, it did something. There we go. Okay, I got too many of these open. That's why. Okay. So the for loop lets us do something for every item. Now, when I'm going through my receipts, I might not know how many are in the stack, right? But what if I wanted to like say, hey, let's total up the number of points we got in our season? Because sports people care about stuff like that. And I know, hey, we play 9 games every season. I want to do something 9 times. Well, I could say, okay, this is game equals 1, and while game is less than or equal to 9, print, or I don't know, we want in score is a int of an input. Enter the score for game number. Now, I remember I have to append in here because we're doing an input, not a print. We can't use the comma separated. Now you can use formatted strings though when you print, which is really nice. Right? That's kind of your shortcut. So you can say, hey, for game number game, because you can use a formatted string here. So formatted strings are our friend. They're super handy here. We'll get the score, and then maybe we want our total score, total points. Right, starts at 0, and we'll take our total points plus equals the score, and then when that's done, we'll print our total points, total season points, total points. Right, so we can do this, it'll run now, but I actually have an infinite loop here because I never changed game. You gotta be careful when you're using loops. If you don't change the thing you're checking, right? I started at 1 and I never changed it. It will always be 1 because nothing inside this block of code changes game. So we want to make sure that eventually I'm going to take game and add 1 to it. Right? So now I can run this code. All right, so score for game 1, maybe we got 10 points and 20 and 30 and 40. Who doesn't matter. We're just making it up here. 80 and 90, 450 points. Awesome. Right? It will total it up. Now, it's kind of annoying if I know I want to do this 9 times to say, hey, start at 1, go until we're less than 9, add 1 every time. Right? Programmers are lazy. We're lazy people. So if I know I'm going to do something 9 times, I can say for, and now I'm going to say game in range 9. So range gives you a sequence of values from 0 up to this number. And really, I want 1 to 10. And the silly thing about range is it doesn't give you the end here. So range does not include the max. So range 1 to 10 will give me 1 through 9, which is really what I wanted here, right? So then I can take my score, add it in here, again, total score, total points, back to 0. Total points is 0. So it saves me a little bit of typing here because I don't need to start it at 1. I don't need to go less than 9. I don't need to add 1 every time, right? It will not be an infinite loop because it's only going to give me this range, which is just a sequence it generates here. So we're going to use ranges a lot because they will run a fixed number of times. Just another way of doing loops here because they're very easy for us. We don't have to do lots of extra typing if we're using our ranges. So again, does the same thing functionally, just sort of a shortcut. Now, what's fun with ranges is you can repeat something a fixed number of times really easily. So if I wanted to say, hey, let's print something out 5 times, right? I don't know, I can say for, I don't know, something in range 5, print test. Now, I don't care what the something is, right? We're just going to throw this away because I don't need this value. So the convention here is use an underscore. Use an underscore as a throwaway. So if you're not going to use the number, because it actually gives you the numbers, right? It will give you 1 and 2 and 3 and 4 and 5. So this one will give me 0 and then 1 and then 2 and then 3 and then 4. So the starting value, so with range here, start is assumed 0. Right, so range 5 is meaning it thinks, oh, you want 0 up to 5, right? So it's the same as range 0, comma 5, right? Same thing. It's assumed it starts at 0. If you give it two numbers, it's like, oh, here's your start number, here's your end number. If you just give it one number, it knows you want to start at 0 and go up to this number. It'll take a little practice till it feels more comfortable. It's okay. It takes a little while. So this will just do something 5 times. Again, this is not a very interesting do something 5 times, but we could repeat something a set number of times pretty easily with a little for loop this way. Now, printing test is not great, but what if we wanted to say like print some ASCII art? You guys remember doing ASCII art? It's you use a character and you could draw things with it. It's kind of fun. You can do ASCII art. I think there's ASCII art archive. .eu. So sure. How about plants? No, no. Oh goodness. Okay, sure. And we want flowers. Here we go. So just using characters, you can print all sorts of cool looking things. This is ASCII art. Okay. ASCII, like the Unicode table. For some reason, it started as ASCII. I don't remember what that even means. ASCII. What is it? American Standard Code for Information Interchange. There we go. So this was the American version before we had Unicode that's actually universal. This is what we started with. Okay, so you can draw stuff, fun stuff. So for our purposes, what if we wanted to draw a rectangle, right? You have so many rows and you have so many columns. So you have a length and a width, right? So I can say for length in range, how about 10? I want to print a star, right, the star character, and I want to print it times, how about 5? Remember, you can multiply strings because Python's fun like that. So I'm going to get 10 rows, let's call this row. So for row in range 10, I'm going to print 5 stars. So if we run this one here, we'll get a nice little rectangle, right? A 10 by 5 rectangle. It's cute. It's a little 10 by 5 rectangle, okay? Now, sometimes, though, depending on the shape, we can't just print it by a multiple here. So you might want to put a loop inside a loop. So I can say for column in range 5, and I can print a single star character. I'm going to change the end to nothing here. Let's print the star character. And then at the end of every column here, I printed 5 columns. Now I'm just going to print, this is go down to the next line. So for every row, for every 10 rows, right, I'm going to go from 0 to 5, or 0 to 4, right? 0, 1, 2, 3, 4, 5 times. I'm going to print a star character. So this does the same thing. This is a loop inside of a loop. It's nested here. Accomplishes the same thing for us. But a lot of times you'll see loops inside of loops, right? But what if we wanted this, instead of to be a rectangle here, what if we wanted to do some sort of triangle, like a right angle triangle? We could draw a right angle triangle, right? We could do something like that. So that's for rectangle here. So let's say, and now let's ask the user, right? So how about the size is going to be an int of an input. How large of a triangle do you want, right? And now this will be how many rows I have, right? So for row in range size, I'm going to do something. So I'm going to have row 0, row 1, row 2, row 3, row 4. And now really, I kind of want 1 to size plus 1. Because I want, if you want a size 5, I want to have 5 stars at the bottom here. In this case, I can print a star character times the row. So row 1 gets 1 star, row 2 gets 2 stars, row 3 gets 3 stars, row 4 gets 4 stars, row 5 gets 5 stars. I'm going to print a triangle. So what size triangle do you want? 6. So 1, 2, 3, 4, 5, 6. We now printed a right angle triangle. Very exciting. Triangle. Oh, there's an L in there. Oops. Now, what if I wanted the other alignment triangle? This one's a little harder, right? So I'm going to change the way I do my loops here, right? So let's print that one, the same thing, but I'm going to print the other direction. Yeah. So the row is, this is row 1, this is row 2, this is row 3, this is row 4, this is row 5, this is row 6. So it's every line. Each line is a row, is what I'm calling it.
Because I haven't seen columns when you use like acts or columns. How does it work?
So it's like in the for loops, It's just a variable name. So I'm just calling this variable row. You can call it A. You can call it zebra, right? It will be given the value of 1, and then the value of 2, the value of 3, the value of 4, up until we hit size. Because of this, we're doing a range. And the for loop says for every item in this collection. So range creates the collection of 1 to size. And then every time this loop runs from start to finish, row has a value. When it finishes, we get the next value. We get the next value. We get the next value.
So row in this case would go for one and two size.
So because range doesn't give you the max value, it'll go from 1 to size, because I'm adding 1 to size so that I will get the size eventually. It'll stop there. Yep. So I can print that. So if I wanted to print the other direction, right? Now we got to pause for a second here, and this is where we're doing some creative problem solving. What's the relationship to where this is and how many spaces I have here, right? At row 1, how many spaces are there before the first star? What's my size minus 1? So this one, this is a 5, sorry. So there's 4 spaces, and then there's 3 spaces, there's 2 spaces, there's 1 space, and then there's 0 spaces. So my spaces will start at size minus 1, eventually I'll get down to 0 spaces. So we can say, hey, I want spaces is equal to my size minus 1. I can say for, this will be row in range size plus 1. I'm sorry, 1 to size plus 1. I can print, now how about for space in spaces, range spaces? We can print a space, and then I'm going to change that ending character to a nothing. After I've printed all my spaces, now I can print my stars. I can print the star character times row. So print as many spaces as I need, then print the row, and then I can take my spaces minus 1. Right? Start at size minus 1 and subtract 1. Now we could just do spaces minus size here. That's your shortcut if you want, and you don't have to deal with any of that. That one's a little harder to conceptualize sometimes. I'm sorry, that is, oh shoot, what do we want? Range, size minus row. This is why this one gets weird. Right? So size minus row, if size is 5, 5 minus 1 is 4, this will give me 4 spaces, right? So just sort of that's a shortcut. I think the other way might have been a little more clear, but that's okay. So let's do 5, and we get 5 this way, we get 5 that way. We're just trying to find out what's the relationship here between the spaces and the stars. Right? So size minus row is a little weird. So sometimes it's easier to just have a variable that you use outside. And you can do that too. Right? That spaces count. Let me leave that in. So those spaces equals size minus 1. And then we said, after we're done, we had spaces minus 1. And this was going to be for space and range spaces. Right? Oh, does that either of those make more sense to you? They both work. It's just whatever style you want here. We'll get that job done. All right, what if we wanted to print all the possible times that a digital clock could show? Because we can make a computer do that. So I can say for hour in range. Now, when you deal with time on computers, the 24-hour clock is much superior to the 12-hour clock with AM and PM. Because it gets really weird, and you have to sort them, you have to look at AM and PM, and the 24-hour clock is just way better. I say for hour in range 24, and I can say for minute in range 60, for second in range 60. Right? So for every hour, we have 60 minutes. For every minute, we have 60 seconds. So this inner loop is going to run a bunch of times for every minute, and we'll run 60 times for every hour. Right? And we can print. Now, using those formatted strings, right, we got lots of options here. So I want hour, and then that is, I want 2 as D, I think for digits, something like that. I think I'll pad it. I forget. We can look it up here. And then I want a colon, and then I want the same for minutes, and I want the same for seconds. I think 2D is what I want here. So the hour, we'll do minute, we'll do second. Let's see if we can print out every possible time. Nope. I did not do the formatting here. Let's see. So Python printf. Digit padding? I think it's padding. Colon 3D. Colon 3D. Colon 2D. Isn't that what I did? I don't want a lining. I want like padding 0, 0 digit. 0 digit padding. Let's see. Percent 2D. I don't want to print with percent signs. 0 2D. That's what it is. So 0. So I have to tell it, hey, use zeros. So 0 is my padding character up to 2 digits. There we go. Right. This will run better now. It'll be very pretty. You're very excited. Here we go. So we get all the possible times showing on our digital clock here. And you can pick one of them randomly, quiz your kids. Right? I don't know. Reading clocks are weird. There we go. And where do we start? So you can put a loop inside of a loop, inside of a loop, inside of a loop, inside of a loop. You can nest loops. They're nested loops. And you can have as many of them as you want. Eventually your head starts to hurt. Because, yeah.
Can you break more than one loop at once?
Break a loop?
Yeah, like more.
So break will just stop the loop, the first loop that it finds. Yeah, we'll get to those keywords on Wednesday. I was going to skip them for now because they confuse me. Yeah, so it'll just stop the first one. All right. How are we doing here? Where did our book go? No design books? Oh, there it is. For loops with range, while loops versus for loops. So what you might want to use them for, right? For loops are really good if you are looping over a collection, or you know how many times you're going to do something. Right? A while loop is much more flexible. It'll just keep going as long as something's true. A loop inside of a loop. Developing a program incrementally is super important. This idea that we're going to write a little bit of code and try it. Write a little bit of code and try it. Write a little bit of code and try it. Write a little bit of code and try it. You don't want to spend hours and hours and hours writing code and then hit run. And then not find out it doesn't work. Because right, you want to build out little pieces at a time and make sure the little pieces work. We started with this idea of this ChatGPT workflow, right? The idea of knowing if it works. That's the hard part. So do you know for a given input what should be spit out? If you can't define that, we have no hope of writing code to do it. Because we need to know what the steps are. How do we get from input to output? I linked this in Discord, if you're on my Discord server. It's in the interesting stuff. This is a great workflow here. Apparently this guy is a data policy lawyer. I have no idea. Never heard of the guy before, but he sounds important. Sure. So write a little bit of code and run it. Write some code and run it. So we're going to try the things as we go, making sure we get what we expect back out. Right? Here's what I intended for it to do. Let me try it and see. Now, to my knowledge, no one has ever written a perfect English paper on the first try. Right? You always have to do an editing process. Professional writers have editors. Their literal job is to write, and they still have editors. So as a professional software engineer, professional developer, data scientist, it's okay to not expect your code to be perfect the first time. Right? We're going to try it, and then we're going to tweak it. We're going to edit it. We're going to fix it. So it's okay if it doesn't work right the first time. It's okay if it doesn't work right the second time. Right? We're going to keep on trying, keep on working, incrementally developing it, little bit by little bit by little bit, testing it, making sure it does what we're supposed to do. That's part of the process. That's what we're learning. Right? Is how to go about doing this. If the only thing you ever do is go look for code from the chat machine and plug it in and go, you're not going to learn if it works. Right? You're going to be in for a world of hurt when you get to the real world and it doesn't do exactly what you wanted it to do because you have no idea how to tweak it. Right? How do I take what it gave me and now change it because it wasn't perfect? Right? That's the skills we're trying to learn. Right? How do we actually use these tools and techniques and tips and different things we can do to solve problems? And how do we know if we're solving the right problem? Right? How do we know here's the input, what the output should be? And that's where things get hard, which is super interesting. It's a very creative process. It's a lot of problems to solve. Did I tell you about the thing with luggage? No? So do you know the first time we were able to get a man on the moon, what year that was? 1969. So we were able to get someone from Earth, put their boots on the moon. Do you know what year someone invented, I don't know if that's the right word, decided they should put wheels on airport luggage so you can drag them with you instead of having to carry them? 1987. So 18 years after we put someone on the moon, someone finally said, why don't we put wheels on our bags? Like, there are all sorts of things that have not been done yet because someone didn't have a creative idea, right? Still problems to solve. Still lots of interesting things to do in the world. Lots of opportunity. Right, computers and AI sorts of things, these large language models, they can imitate. They can't create things, though. Right? They can say, hey, I've seen something similar. Here you go. It's something similar. It's not going to come up with the new stuff, though. Right? And that's the interesting piece. And as you get into data science, one of the reasons why the program is structured the way that it is, where you learn a lot about data science, but then you also take a bunch of classes in something else, is you need to know a lot about that something else. Hey, I want to know a lot about finance. I want to know a lot about healthcare. I want to, oh my goodness, I can't talk. You get the idea. About a specific domain. Because you need to know what questions to ask the data. Right? We can't just throw a bunch of data at a computer and have it give us information. Right? We need to look at what are we trying to find? What patterns are we looking for? How do we know enough about this other thing to see what it means in the data? Right? That's why we're building all those skills together. Right? It takes that. Did I show you the little Venn diagram? Science Venn diagram. This one's good. Is it? I think it's this one here. Yeah. So sort of this trifecta. Such a good word. Love that word. Of knowing math and stats, knowing computer and programming, computer science, and knowing the subject matter. If you know the subject matter, you have the math and stats, you can do the quantitative research. If you know the subject matter and you have computer and computer science programming, but you don't know math and stats, this is the danger zone. You're going to come up with bad information. He's like, hey, look, this is a correlation, not a causation. Correlations are not causations, right? I think hopefully you've learned some of that in stats by now. I'll show you a cool website in just a second. Right? If you don't have the subject matter expertise, but you know math and stats, you know computer programming, computer science, you can start doing some of the machine learning stuff, but you don't know how to apply it. You don't know how to ask those questions here. Correlations. There's a whole website. Suspicious correlation. I think it's this one. Here you go. U.S. spending on science-based and technology correlates with suicides by hanging, strangulation, suffocation. This data looks very similar here. They're correlated. There's no causation here, right? All right, so it's a number of people who drowned by falling into swimming pools and the number of films Nicolas Cage appeared in. There's a correlation of the data here. Obviously, we need to keep Nicolas Cage out of films. Like, this sort of just ridiculous things. Per capita consumption of cheese and number of people who died by becoming tangled in their bed sheets. There's a correlation here, right? The correlation doesn't mean causation. So that danger area, right? You know computer programming and you know your domain, but you don't have the math and stats background to understand what the data really means. You're like, hey, these are related. Let's feed people less cheese and save lives. No. Doesn't work like that, right? So that sort of thing, as you're picking up all the different skills here, it's super interesting. A lot of stuff will go into it here. It's a lot of fun. Where did it go? There's this one here, right? I closed out. Did I lose it? There it is. So that's what we're aiming for, right? Somewhere in here, there's ethics. You're going to get in the program, thankfully. I'm also scared of this sort of thing without ethics. But that's a whole other story. We get more into that in next semester. We have a whole seminar bit on ethics, which is fantastic. We should talk more about it here. Because you can do really bad things with data, right? Really bad things happen with data when it's applied improperly. And there's some pretty scary stories of things that have happened and we're like, hey, this is what the data says. It's got to be true. Like, okay, and we'll get to that later. So, right, loops. We're going to finish up loops on Wednesday. We'll have enough. We can do some labs on loops. We're going to try and draw some shapes. We'll do some other loops. We'll find the standard deviation of a bunch of numbers that you can enter, which is super fun. I know there's a shortcut, but we're going to do it the hard way because we're practicing the loop. That's all. All right, questions, thoughts, concerns? You okay? We'll meet up in lab in about 25 minutes or so, and we'll go from there.